And here are some more examples when we are dealing with stoichiometry and limiting reactant. So again, reminder, the balanced chemical equation is the most important part here because it provides us the mole-to-mole ratio that is essential for stoichiometry, right? It provides mole-to-mole ratio. So I know I keep saying it, but remember, when in doubt, mole it out. Lucky for us, this example here has moles in it, so we don't need to do anything in order to use the balanced equation. We can use it with the values as is. So this question is similar to that one where I was asking how many pancakes can be made if we have this amount of each ingredient. So whatever chemist was noticing that they have 2 moles of H2 and 3 moles of Cl2, and they want to know which one's the limiting reactant. And I mean, this one, it's clear because it's a 1-to-2 ratio for both of these elements, but I'm going to be explicit in showing this in the math so you can see what we need to do. So remember, the limiting reactant is the one that limits the amount of product that can be made. So if we can figure out how much product we can make from 2 moles of H2, and then also how many moles we can make from 3 moles of Cl2, then whichever one gives us the least amount is the limiting reactant. So we can do that, right? 2 moles of H2 are going to react, and for every 1 mole of H2, there we get 2 moles of HCl. And then if we have 3 moles of Cl2, well, for every 1 mole of Cl2, we get 2 moles of HCl, and I forgot to put moles up here. Remember, we have to have 2 parts to our unit. We're talking about moles, but more specifically moles of HCl. So with this, notice that we turned both of them to the same substance, right? We turned them both to hydrochloric acid so that we can compare and say, okay, this is the least amount of HCl that can be made. So the limiting reactant, or capital LR for abbreviation, the limiting reactant is H2 because, again, it limits the amount of product that can be made. So when we're doing this, when we're doing this reaction or this problem, we are comparing the substances that we have and figuring out which one gives us the least amount of that product. So then it says how much of the excess reactant is left. So first we had to identify that H2 is left. Remember, you use up all of the limiting reactant, and then we have to figure out how much of the chlorine we used, because if we're thinking about leftover, we're thinking about started minus used. All right, so we know we start with 3 moles of Cl2, so we want to know how much did we use and how much do we have left over. So this next part here, I'm actually going to keep it kind of color coordinated so that we can say we're trying to figure out how much Cl2 was used. And what we do know, right, we can take 2 angles at this. We can either say, I know I make 4 moles of HCl, or I know that I use 2 moles of H2. It doesn't matter where you start, just as long as you're using something that is related to the limiting reactant, either the least amount of product you can make or the substance we use to get there. Let's just use the H2. And we're trying to figure out how much Cl2 is used. So the last problem, we went from H2 to HCl. In this case, we're going to go from H2 to Cl, right? Straight to the other reactant. So I know moles of H2 go on the bottom and moles of Cl2 go on top. This is a 1-to-1 ratio. So for every 2 moles, if we use 2 moles of H2, we also use 2 moles of Cl2. It won't always be this 1-to-1 ratio, and it might not be super explicit what's going on. So that's why I'm being so drawn out with the examples so that we can see how to do this problem. So this right here, this 2 moles of Cl is not the answer because this is 2 moles of Cl2 used. We are interested in how much we have left. So we have one more step. We started with 3 moles of Cl. And we're going to subtract the amount used, which was 2 moles. So our answer is 1 mole of Cl2 left. Okay, So when you're doing other problems, you can always come back to this to get the blueprint for how to do these problems. So when we are going, the next example that we have that I'm actually going to leave you to do, we have silicon and nitrogen reacting to form silicon nitride, right? Trisilicon tetranitride. And we have this problem here where it says, what is the limiting reactant when 2 grams of silicon reacts with 1.5 grams of nitrogen? Now, two things are happening here. One, I do not have moles. And two, we don't have a 1-to-1 ratio of reactants, right? So it's not as simple as this one up here, where clearly it was a 1-to-1 mole ratio. I had 2 of hydrogen and I had more chlorine, so therefore the hydrogen is going to be the limiting reactant. In this case, it's not as easy as a 1-to-1 ratio, and we also have masses. So remember, when in doubt, mole it out. If I can spell, if I could really spell, and if this would, oopsies, if this would actually erase. Right? If I'm going to use this 3-to-2 ratio, it has to be in moles, right? This is mole to mole ratio. So I need to get those masses into moles, but we're still following the same guidelines. We're trying to figure out which one limits the amount of product that we can make. So I can turn 2 grams of silicon into moles, and once I have it into moles, we can figure out how much product we made. And we can do the same thing with nitrogen, and then we're going to compare which of those two gives us the least amount. I did this on purpose. We're going to notice that it's not always as simple as whichever one gives me the least amount of mass, right? So I know that I have 1.5 grams of nitrogen, but does that mean that it is going to be the limiting reactant? You're going to have to do the problem to figure that out. And then it says, after you do that, if you figure out the limiting reactant, it says how much of each substance is left at the end of the reaction. And I actually didn't finish the slide up here. It says how much HCl can be made. We already answered that question. I'm gonna show you, circle it in green. We figured out, based on doing the limiting reactant, how much HCl can be made. We can make 4 moles of HCl. This part down here, how much of each substance is left at the end of the reaction, I'm going to be specific in grams. That's including the product. So how much product did we make and how much of each reactant is left over. So try your best to utilize the ideas that we saw up here when we're dealing with moles, but hopefully we understand that we need to turn these grams to moles, and while it seems more complicated, it actually is all essentially the same question. We are just turning things from moles of one thing to moles of another and comparing those to see which one gives us the least amount, and so on. So again, try this on your own, and I'll post the answers in here so that you can see how you